You take a piece of aluminum foil out of the kitchen drawer, the same stuff that wrapped yesterday's leftovers. You crumple it into a loose ball, dip it in plain water, and rub it on a rusted chrome chair leg. And the rust just lifts. No spray, no chemical, no gloves. Black residue appears on the foil, and underneath it, clean metal stares back at you like it's been hiding there for years. Now here's what doesn't make sense. Aluminum foil is soft. You can tear it with your bare hands. Everything we were ever taught says hard removes hard. Sandpaper, steel wool, abrasive pads. So how did the softest thing in your kitchen just do what a $15 bottle from the hardware store couldn't? That's the case we're opening today. And the answer isn't what you'd guess. It isn't friction. It isn't scrubbing. There's a chemical reaction happening between that foil and that rust, a real one with real science behind it. And the reason nobody ever taught it to you has nothing to do with the science being wrong. It has everything to do with who profits when you don't know. Now, if you've been following this trail so far, and it's making sense to you, I want to ask you something. Before we go any deeper into the case, hit that subscribe button. Not because I need the number, because we dig into things like this every week. Old knowledge, simple fixes, the stuff that works but nobody sells. If that's the kind of thinking you want in your feed, this is the place. All right, back to the evidence. Let me set the scene for you. There's a pair of chrome bar stools, the kind your parents might have bought in the early 60s. Good bones, solid frames, just decades of neglect showing as brown-orange rust spots creeping up the legs. You've tried everything. Magic erasers, dish soap, metal polish from a tube that cost you $9 and did almost nothing. You're one step away from steel wool, but you know that'll scratch the chrome to pieces. Then someone mentions aluminum foil and water. Sounds absurd. Sounds like the kind of thing your uncle would say after his third cup of coffee on a Saturday morning. But you try it anyway.
And it works. Not slowly, not partially. The rust comes off in smooth strokes. The foil conforms to the curve of the metal, and what's left behind isn't scratched, isn't dulled. It's clean, almost polished. The foil itself turns dark, like the grime migrated from the steel onto the aluminum. You flip the foil, dip it again, keep going. 2 minutes per leg. Total material used, maybe 8 inches of foil and a cup of tap water. Total cost? You'd have to measure it in fractions of a cent. And the $15 model of rust remover is still sitting sealed in the garage.
Now stop here for a second, because this isn't a life hack video. I'm not going to tell you it works and move on. Something happened in that interaction between foil and rust. Something chemical, something real. And understanding what it is matters more than the trick itself. Because once you understand the why, you don't need anyone to teach you the what ever again. You become the person who sees rust on a gate hinge and knows exactly what to reach for, and exactly why it'll work. That's not a hack. That's knowledge. And it starts with a question that sounds simple but isn't. How does something soft remove something hard? Here's your first clue. The answer isn't friction. When you rub sandpaper on metal, that's abrasion. Hard particles grinding softer material away. If aluminum foil worked by abrasion, it would scratch chrome. It doesn't. People have used this on polished chrome bumpers, vintage motorcycle parts, antique furniture legs. no scratches. That rules out mechanical scrubbing as the main driver. So what's doing the work? Chemistry. Real, measurable, documented electrochemistry. The kind that shows up in textbooks if you know where to look, but never shows up on the label of a rust remover bottle, for reasons we'll get to. Here's what happens at the molecular level when wet aluminum touches iron oxide, which is what rust is. Aluminum has what chemists call a reduction potential of about -2 volts. Iron sits at about -0.45 volts. That gap is enormous. It means aluminum is far more eager to bond with oxygen than iron is. So when the foil meets the rust, the aluminum pulls oxygen atoms away from the iron oxide. It literally dismantles the rust molecule by molecule. The water between them acts as a mild conductor, letting this exchange happen. The friction generates a little heat, which speeds the whole reaction up. This is not scrubbing. This is one metal chemically outcompeting another for oxygen. But there's a second thing happening that nobody talks about. When the aluminum gives up its electrons and bonds with that stolen oxygen, it forms aluminum oxide. Now, aluminum oxide is harder than steel, much harder. And the tiny particles of it that form during the rubbing, they act as a microscopic polishing compound right there on the surface. So in one motion, you're doing two things at once. You're chemically dissolving the rust, and you're physically polishing the metal with a compound that's being created in real time by the reaction itself. Two invisible processes, one visible result. That's why the chrome looks almost better than before, not just clean, but slightly buffed. A $15 product wishes it could do both.
So now the question shifts. If the chemistry is real, and it is, this is basic electrochemistry, nothing exotic, then why isn't this common knowledge? Why isn't it printed on the back of every foil box? Follow the money, and it makes sense fast. Naval jelly runs $8 to $12 a jar. Evaporust goes for $12 to $22 a gallon. WD-40 sells a specialized rust remover for $10 plus. These are real products made by real companies with real marketing budgets. A roll of aluminum foil costs $1 or $2 and handles dozens of rust jobs. There's no foil company spending money to advertise a rust trick. There's no brand, no label, no sponsored shelf space. No one profits from telling you the answer's already in your kitchen.
And that's not conspiracy. I want to be clear about that. No one sat in a boardroom and decided to suppress the foil trick. It's simpler than that, and honestly more important to understand. In a marketplace, the solutions that get amplified are the ones someone can sell. The solutions that are essentially free, they travel by word of mouth. They live in old bike shop conversations and grandpa's workshop and internet forums where nobody's making a dime. The foil trick has been quietly known for decades by restorers, gunsmiths, chrome collectors. It just never had a marketing department. And that tells you something about how knowledge moves in a product-driven world, or more accurately, how it doesn't.
So let's keep pulling on this thread. We've got the chemistry. It's real. We've got the economics. They explain the silence. Two solid clues pointing the same direction. But an honest investigation doesn't stop the moment things start looking good. It asks the harder question. And the harder question here is this: does this work on everything? Is there a catch?
Because if I stood here and told you a crumpled ball of kitchen foil fixes every rust problem on earth for $1, you'd be right to call me a liar. And your instinct would be correct. There is a catch. More than one, actually. And knowing them is what separates someone who understands this trick from someone who just heard about it online. Here's where the foil trick shines. Genuinely, reliably, no exaggeration. Surface rust. The orange-brown film that forms on chrome chair legs, garden shears, hand wrenches, pliers left out in the damp, steel shelf brackets in the basement, old fixtures in the bathroom. The stuff that looks ugly but hasn't eaten deep into the metal yet. For that kind of rust, foil and water is remarkable. You crumple an 8-inch sheet into a loose ball, dip it in plain water, and rub with moderate pressure. The foil conforms to curves and threads. You'll see black residue forming. That's the reaction working. Wipe clean with a damp cloth, then dry thoroughly. Moisture left behind is how new rust starts.
Now, if the rust is a little tougher, a little more stubborn, a little more orange, you can swap the water for white vinegar. The mild acid gives the reaction extra help. But here's a caution worth stating plainly. Vinegar is fine on steel and chrome, but keep it away from copper, brass, and aluminum itself. It can discolor or damage those surfaces. On steel and chrome, though, foil plus vinegar handles the middle ground rust that plain water might struggle with. Each piece of foil breaks down after a few minutes of rubbing, gets brittle, tears apart. That's normal. Just flip it or tear a fresh piece. You'll use maybe 2 or 3 sheets per job. Total cost? Still pennies. But here's the clue in this case that we can't ignore.
And I'd rather be the one who tells you than let you find out the hard way. Deep rust. The kind where metal has been pitting for years, where the surface is cratered and rough, and the orange goes down into the structure of the steel itself. Foil can't fix that. Nobody can uncrater metal. The iron that was there is gone, converted to oxide and flaked away over time. Foil will clean the surface rust around those pits, sure, but the pits stay. Similarly, heavily corroded bolts where rust is locked into the threads, foil helps topside, but it can't reach inside a seized joint. There's another honest limit worth naming. This method takes elbow grease. You are physically rubbing piece by piece, surface by surface. For a couple of chair legs, a set of tools, a chrome bumper section, that's fine. Satisfying even. But if you're looking at an entire rusted chassis or 100 bolts from a barn-find tractor, foil isn't the practical answer. That's where a soaking solution like Evaporust genuinely earns its price. You submerge parts overnight, and chemistry does the work while you sleep. And on anything structural, car frames, load-bearing brackets, plumbing joints, rust that deep is a safety question, not a cosmetic one. Get that assessed by someone who knows what they're looking at.
So now let's connect everything and see what picture forms.
Clue 1. The chemistry is legitimate. Electrochemistry documented in standard reference tables. Nothing invented, nothing exotic. Clue 2. The market economics explain perfectly why this knowledge never reached mainstream awareness. Clue 3. The trick has real, honest boundaries that actually make it more credible, not less. When you put them together, the picture is clear. This isn't a miracle. It isn't a gimmick. It's a specific chemical reaction that handles a specific range of rust problems, and that range happens to cover the vast majority of what most people encounter in daily life. The chrome in your kitchen, the tools in your shed, the fixtures in your bathroom. Everyday rust. Dollar store solution.
And that brings us to the verdict. The foil trick is real. It is chemically sound, it costs almost nothing, and it belongs in every workshop drawer, every kitchen, every homestead toolkit in the country. Not as a replacement for every rust situation that exists, but as the first thing you reach for. Think of it as a simple decision. Rust shows up on something you own. Step 1, foil and water. If that clears it, you're done. Cost, pennies. Time, minutes. If the rust is deeper than foil can handle, then consider a commercial product. That order alone, trying the free thing first, will save most people dozens of dollars a year on problems that never needed a store-bought solution in the first place. Here's what I want to leave you with.
This was never really about aluminum foil. It was about a pattern. The pattern where simple things that work get buried under complex things that sell. Baking soda, vinegar, salt, lemon. How many kitchen drawer solutions do exactly what a $15 bottle promises? But nobody advertises them because there's no margin in free knowledge. The foil trick is one case, but the principle underneath it is the one worth keeping. Before you buy a solution, ask whether the science already exists in your house. That's not being cheap. That's being the kind of person who understands how things actually work. And in a world that'd rather sell you the answer, that understanding is worth more than $1. It might be the most valuable thing in your drawer.